So as I was recording the practice test video 1, I realized that it was already getting too long, so I ended that video, and we're going to call this one video number 2, and that's technically questions 8 through 17, the rest of them. Let's jump right into question number 8. Question number 8. All right, so we have technically it's a compound inequality. It has one inequality, another inequality with the word "and" between them. So let's think about this word "and." It could be a little tricky. When you get an answer for this one and an answer for this one, you want both the left answer and the right answer. The word "and," what does that mean? Like if I told everybody, whoever has blue jeans on, stand up, okay? And then if I said, whoever has a red shirt on, stand up, okay? Now, if I said, whoever has blue jeans or red shirt, stand up, then a lot of people would stand up. But if I use the word "and," whoever has blue jeans and a red shirt, then that would be a different story. It'd be just a small amount of people because both have to happen. The word "and" implies an overlap. They have to have blue jeans and a red shirt. In this case, you have two inequalities, and wherever they graph, you need the "and" part, the overlap part. Okay, and we'll get to that in a bit. But right now, let's begin by solving each of these. I'm going to do it over here on the side. So let's work on the left one first. You're going to add 3, you're going to add 3, you're going to end up with the new inequality 2x is greater than 18. That's really a 2 times x is greater than 18. Get rid of the multiplication of 2 by dividing by 2. You're going to have x is greater than 9. Okay, so that's an answer, and we'll graph it in a bit. Let's solve the other one first. The other one, I'm going to subtract 3. We will have negative 7x is less than, I don't flip the symbol, I didn't divide by negative yet. 24 minus 3, that's 21. And now for my final step, I really do have a negative 7 times x. So I need to get rid of that multiplication of negative 7 by dividing by negative 7, dividing by negative 7. And our answer will be x. You have to flip this symbol because we did divide by a negative. It's going to become a greater than symbol, and this is a negative 3. Okay? So keep in mind the word "and" is between these two answers. So the word "and" implies that they want the overlap piece. Okay? If it exists. If it doesn't exist, you might type in no solution. So in this case, let's go to a number line. Put the smaller number, in this case the negative number, on the left side, the bigger number, the positive 9, on the right side. Now let's graph this thing. Let's begin with this guy right here in red. X is greater than negative 3, greater than, open dot, to the right. And this other one I want to do in blue, it says x is greater than 9, greater than 9. Okay, so what this means is that you want to represent just the overlap. So imagine this, the x is greater than negative 3. It's going to the right, it's keep going, it keeps going all the way this way forever. And of course, the other one, x is greater than 9, starts at 9 and it keeps going to the right forever and ever and ever. So where's the overlap happening? I want to highlight it. It starts right here at the open value of 9, going this way forever, going to the left forever. So how do you describe from the open dot 9 to the right? What that really means is x is greater than or greater than 9. And that's it. That's your only answer. This is not a compound inequality, negative 3 on the left side, 9 on the right side, x in the middle. That would be wrong, specifically because of the word "and." Okay, the word "and" means that you want both to happen. This one and this one. And in order for that to happen, you got to look at your graph and look at the overlap piece. Okay? It's kind of like saying, I want you to stand up if you have blue jeans and a red shirt, right? Now, if this would have been the word "or," imagine that. If I say, go ahead and stand up if you have a red shirt or blue jeans. So you would start standing up right here at negative 3, if that makes sense. So if it would have been an "or," then your answer, your single answer would have been x is greater than negative 3, because that's a red shirt, and over here, red shirt and blue jeans. So the word "or" would just be on this one. The word "and" has to be both, which implies the overlap which is from 9 to the right, which is x is greater than 9. Okay, so let's double check, or let's look for that answer over here. And as you could see, the answer is x is greater than 9. That's this one right here. You would select this one. It's multiple choice. All the other ones are incorrect. This guy is the correct answer. Let's move on. This one's a little nicer. It says if you were working on a compound inequality, okay, so imagine you had a complicated compound inequality and you started solving, and you had the word or between it, right? Okay, there's a word or between it. So if you were working on a compound inequality and got the above statement as your answer, you got x is less than 1 or x is less than 5, which of the following would be the correct final answer? Think of a graph on a number line. Okay, so you actually need to go to a number line. You need to actually graph this guy. X is less than 1. So here's 1, less than is to the left. Okay, and then you got to graph the other one. X is less than 5. Put 5 on the right side. It's bigger than 1. And it's also less than. Okay, and what's really important here is the word or. Whoops, I erased the, or over, I wrote on the R. It says O. Or, right? The word or means that you want, it doesn't have to be both at the same time. It doesn't have to be the overlap. It's just the first one that begins, right? So this red one, it starts overlapping from the one this way, but we don't care about the overlap. That would be the word and. Right here, the word or, where does it start existing, right? It doesn't start existing at 6 or at 7 or at 8. It starts existing at 5. Well, technically right below 5 because it's an open dot. So it starts existing here. So right here, what do we have? We have a red one. Would it satisfy the statement, the red one or the blue one? Yeah, it does. Over here, red or blue? Yeah, there's both technically. Okay, so it starts here going that way forever. I might as well highlight it. It starts right here and goes this way forever, like that. So what inequality describes that it starts here and goes this way forever with an open dot? That is x is less than 5. Okay, so right here you don't have a compound inequality. It's just the answer x is less than 5. Okay, let's move on. Number 10, they want us to write the absolute value inequality shown on the number line above. In order to really understand this question, we should go back to the notes that we had on this section. And as a matter of fact, these notes are expressing the same exact question. As you can see, it's the same number line down here, area that's together between -5 and -1. And the notes to writing it is the absolute value of x minus the midpoint equals the distance from the point to the midpoint. Okay, so let's first begin by finding out what the midpoint actually is. So if you have a point here and a point there, where's the point in the middle? It's clearly right here, the -3. Okay, so I'm going to put just a little blue mark to let you know that -3 is the midpoint. So let's begin writing our absolute value inequality. You have the absolute value of x minus the midpoint, which in this case is -3. Close absolute value. Now, we have an equal sign here, but we know that this is not an equal sign. It's an area, so it's an inequality. And that's where the notes come in. It says, but instead of an equal, you need an inequality. If the areas are apart, use greater. And the reason why I put OR in red is because if they're apart, usually it means that it's going that way or that way, right? Or implies that they're apart. But if the areas are together, use the less than symbol. So the areas are obviously together, and that kind of makes sense because it's between here and here. It's kind of like it has the and sound as the less than. So we know that these areas are together, so we're going to use the less than symbol. So here's our symbol, less than. Not only that, we know that they are solid dots, so we're going to put less than or equal to. And now what do we need over here? It says the distance from the point to the midpoint. So what is the distance from the midpoint to the point, or from the point to the midpoint? It doesn't matter which point you use. When you say how far is it from here to the midpoint -3, it's 1 unit, 2 units. So that will be a 2 out there. Or if you went this way, 1 unit, 2 units, it's still 2 out there, okay? So once again, here's your notes. X minus a midpoint, close absolute values. Instead of an equal sign, if the areas are apart going that way or that way, you're going to put a greater than symbol. If they're between here and here, you're going to put a less than symbol. So that's why we put a less than. They are solid dots. We put or equal to. And the distance from the point to the midpoint is 2. Okay? So there's your absolute value equation. The only other thing, the only other thing that you could do to make this look nicer is to change the minus minus to a plus plus. Okay? So your final answer should read absolute value of x plus 3, close absolute value is less than or equal to 2. That is the absolute value equation. The absolute value inequality that is represented with this graph, this number line. Okay, so if we go back to the original question, we'll recognize that it's a multiple choice one, and you need to find this one in the multiple choice. I know you can't really see it right here. They're kind of shaded, but if you look through all the options, none of those options are there. So in this case, none of these would be the correct answer. Let's move on to the next question. We have another write the absolute value inequality shown on the number line above. Once again, you need to know your notes on this section. It's the absolute value of x minus the midpoint, I want to just abbreviate it, MP, close absolute value. Now, instead of equals, if the areas are apart, it's going to be or, right? That way or that way. And what sounds like or? The greater than symbol. The greater than symbol. In case you forgot, let me just go back to the notes here. Here they are. To write an absolute value inequality, you got your absolute values, x minus the midpoint. Instead of equals, you need an inequality. If the areas are apart, use greater. And if the areas are together, use less than symbol. So in this case, they are apart, so I will use the greater than symbol, okay? These are open dots, so I don't need to put a solid line underneath that greater than symbol. And the number that belongs over here, once again, if we look at our notes, it's the distance from the point to the midpoint. So let's go back. And what is the distance from this point, this point to the midpoint, or from this point to the midpoint? It looks like the midpoint is 0, right? Yep. And it is 2 spaces away. So the distance is going to be 2. So instead of writing the MP, let's actually plug in that midpoint value. And we said that the midpoint value is 0. And instead of writing distance from point to midpoint over here, let's actually find that distance, which is 2. So this is your absolute value inequality that's represented above. The only other thing you could do to make this look nicer is put the absolute value of x. You don't really need a minus 0. X minus 0 is just x, is greater than 2. Is greater than 2. So this is your answer for this particular problem. This guy right here, the absolute value of x is greater than 2. And of course, you're going to have to select that on your multiple choice answers. Alrighty, jumping to number 12, we have this absolute value equation, and they're not telling you to solve it. It's very important that we always read instructions. It says, when you solve an absolute value equation, you must set up your positive and negative situations. They're actually telling you what to do. Of course, that's only after it's isolated. Like if you had a 7 here, you'd have to divide by 7, divide by 7. Or if you had a plus 3, you'd have to subtract 3 and subtract 3. Anyway, what would be your negative situation to the above problem? So here's your problem. It's already isolated. If you did do the positive situation, you would write it exactly the way it is. If you did the negative situation, you would write it exactly the way it is, but you'd have to change this sign. So what is the negative situation? Again, let me actually show my positive situation. The positive situation will be 2x plus 1 equals negative 5x. You just write it exactly the way it is. The negative situation, it's the same 2x plus 1, but you have to change the negative 5x. You have to change it to a positive 5x, right? So that would be the negative situation. That's all they're asking for. And which one of these has that 2x plus 1 equals positive 5x? 2x plus 1 equals negative 5x. 2x, negative 2x plus, okay, well, none of these. So that means that none of these is the correct option. Let's check that. Absolutely right. None of these is correct. If you check the other ones, they're all wrong. Okay, so yeah, none of these is the correct answer for this problem. Let's move on, number 13. We need to solve. It's an absolute value equation. Okay, so we need to set up our positive situation and our negative situation after it's isolated. Remember, first step is to isolate your absolute value. What do we have here? We have 2 times the absolute value. So let's get rid of that multiplication of 2 by dividing by 2. What I do to one side, I do to the other side. I will have the absolute value of 3 minus x, close absolute value, equals, I could actually do this. Negative 8 divided by 2 is a negative 4. And of course, the x will still be there, negative 4x. Okay. So now that it's isolated, now I could do my positive situation and my negative situation. Okay, so for the positive situation, we're just going to rewrite it exactly the way it is without the absolute values. For the negative situation, same exact thing, 3 minus x equals, but instead of a negative 4x, I need to change the signs and make that a positive 4x. Okay, that's all you do for the negative situation. Now, if it would have been an inequality, I would have flipped the inequality as well on the negative situation. But it's not an inequality, it's an equation. So let's continue, let's solve both of these. I am going to get the x to one side. So I'm going to add x. I'm going to have 3 equals, what is negative 4 plus 1? That's negative 3 with an x. Final step to get x by itself, I would have to divide by negative 3, divide by negative 3. I will get the answer negative 1 equals x. And of course, the better answer would be to write the x on the left side and the negative 1 on the right side. That is my possible answer. I say possible because I still need to double check it and make sure I don't get extraneous solutions. Let's solve the negative situation right now. Let's get the x's to one side and the numbers to the other. So I'm going to add x. So I end up with the 3 coming down, the equal sign. 4 plus x, 4x plus 1x is a total of 5x's. Now I still need to get rid of the multiplication of 5 in front of the x. I'm going to divide by 5, giving me x equals 3/5. Better written x on the left side, 3/5 on the right side. So that's a possible answer as well. Again, I say possible because we still need to double check, plug them back in and make sure we don't get extraneous solutions. Now, you could plug it into the original if you want, or you could plug it into your isolated absolute value equation, okay? So here's a fact. When I plug in a negative 1 right in there, I will have the absolute value of 3 minus a negative 1 right in there, negative 1, okay? Then you close the absolute value. So what is minus negative? That's really plus plus. So I really got 3 plus 1, which is 4, and the absolute value of 4, does it equal negative 4 times negative 1? Yeah, it'll be 4 equals 4. Okay, I hope that makes sense to you guys. The absolute value of negative 4 is going to equal to negative 4 times negative 1. Okay, that's 4 equals 4. So this does work. I've double checked it. This one works for sure. Now, if I test this next value, plugging in a fraction, yes, I could plug in a fraction right here, but we know that the absolute value of something can never equal a negative value. And if I were to plug in the fraction over here on this side, this is a positive number. If I say a negative times a positive, that will be a negative answer. And we know that that's impossible. You can't do the absolute value of something to give you something that's negative, a negative number that is. Okay? So when you plug in 3/5 right there, that'll become negative 12/5, and that's impossible. You can't do the absolute value of something to give you the answer negative 12/5 or any negative number for that matter. So make sure that you cross this one out. That one's extraneous. The only answer to this question is x equals negative 1. So let's take a look at the actual question Number 13, notice that they give you these multiple choice answers. They actually give you the two answers that we got. They give you the -1 and 3/5. That's incorrect. Why is it incorrect? Because the 3/5 was extraneous. It didn't work. It's only -1. So this is the correct answer. X equals -1. That's the only one that you pick. Don't pick the other ones. Number 14 is a pretty straightforward question. They're telling you to evaluate, not solve. So what we want to do here is plug in the A value of -2 and the B value of 1 right in here and right there. So let me rewrite the whole thing. I have the absolute value of 1 minus 7 times B. B is 1. Close absolute value, right? Close absolute value minus the absolute value of A. So let me write minus the absolute value of A, but we know that A is -2. Let's close absolute value. Once again, we have A in the absolute value. A is -2. I put the -2 in place of the A. So all we're doing is plugging in our -2 right there and our 1 right there. And if you rewrite it, you get what I just wrote up here. All right, so let's work on the first absolute value. We really have -7 times 1, that is -7. So I have a 1 minus 7 inside of the absolute value. That is a -6. And of course, the absolute values are still there. And the absolute value of -6 really is +6. Okay, so I hope we see how we went from here. 7 times 1 is 7. Bring down the 1 and the minus, 1 and the minus. 1 minus 7 is -6. The absolute value of -6 is 6. Over here, I do not change this to a plus plus. That's incorrect. You actually have to do the absolute value first. The absolute value of -2 is +2. And then you could bring down the minus sign, okay? So what you really have here is 6 take away 2. 6 take away 2 is 4, okay? So the correct answer is 4. Check it out. You actually have to type in 4. Now this was not an equation, so you don't type in x equals 4. That's not an equation. You just simplify it. Your final numeric answer is 4. Let's move on to number 15. Okay, so on number 15, we also have an absolute value inequality. We have multiple choice answers. This is a good one. I like this one. It's very entertaining. We got to solve it first by, well, to solve it, you first have to isolate the absolute value. So you don't want the -6 and you don't want the 2. So I rewrote the problem down here to make it a little easier for us and to have some space to work. So I want to isolate the absolute value. I want to get rid of that -6 first by adding 6 and adding 6. So my new absolute value inequality will be 2 absolute value of 7x plus 7, close absolute values, greater than or equal to 14. Okay, and then final step, I need to divide by 2 to isolate it, and divide by 2. I didn't divide by a negative, so the inequality is not going to flip. I have the absolute value of 7x plus 7, close absolute value, is greater than or equal to 7. It's a lot of 7s. Lucky number 7. Anyway, I want to rewrite it up here. That's the absolute value of 7x plus 7, close absolute value, is greater than or equal to 7. Now that it's isolated, I could do my positive situation and my negative situation. The positive situation is writing it exactly the way it is without the absolute values. That's 7x plus 7 is greater than or equal to 7. The negative situation is the same exact thing, 7x plus 7, but we're going to change the inequality and also change the sign of the right side of that 7 right there. So now we're going to solve both of them. We have -7 minus 7. This cancels out. We end up with 7x is greater than or equal to 0. A lot of people freak out with that. Don't. 0 is a number. What this really says is 7 times x is greater than or equal to 0. So let's get rid of that multiplication of 7 by dividing by 7. What I do to one side, I do to the other. I'm going to end up with x is greater than or equal to 0 divided by 7 is still 0. Okay, so that's one possible answer there. Let's go to the other and solve it. We are also going to subtract 7, but now we're going to have 7x is less than or equal to -14. And now my final step would be to divide by 7. Again, the inequality does not flip. This cancels out. X is less than or equal to -2. So we have another answer here. Now, what we need to do is go to a number line to determine if the areas are together. And if the areas are together, I'm probably going to write it as a compound inequality like this. Or if they're apart, which would imply that we would keep the inequalities, these two inequalities, apart with the word or between it. Okay, so I don't know that for certain yet, so let's go to a number line. I want to do it right here in red. Here's my number line. We have the smaller number, -2, on the left side, the bigger number, 0, on the right side. And let's go with the x is greater than or equal to 0. Greater than is to the right. And if we go with this one, x is less than or equal to -2, less than is to the left. So the areas are apart, which means that it does need the word or right between them. So what is the correct answer? It is x is less than or equal to -2, or x is greater than or equal to 0, which is clearly that one right there, this guy up here, the word or between them. It's not this one, it's this one, okay? All the other ones are incorrect. All right, so on this question it says, whoops, I already showed you the answer, my bad. It says, let's say you're solving a multi-step compound inequality that has the word and between it. All right, so you have a crazy inequality, the word and then another crazy inequality, and you solve both of them and you get two answers, but the word and is between them. Okay, and let's say you get this as an answer. X is less than -2 and x is greater than 1. So do we write this as a compound inequality? Or is it going to be this one or that one? Is it going to be no solutions? They're all real numbers. We need to determine that. So let's actually do this by thinking of a number line. So here's my number line. Smaller number, -2 on the left side, bigger number, 1 on the right side. And let's do this one in red. X is less than -2, open dot to the left. And this one, x is greater than 1 to the right. This is apart, which means that it should have the word or between them, but it doesn't have the word or. It has the word and means that they have to overlap. They have to overlap, okay? So where do they overlap? Do they overlap on this side? Do they overlap in the middle? Do they overlap over here? The answer is that they don't overlap. So because of the word and being right here instead of or, because of the word and being right here, they have to overlap and they don't overlap. So what does that mean? Where do they overlap? They never overlap, which means no solution. So the correct answer is no solution, okay? Let's move on to this last one. I want us to solve this compound inequality. It's two inequalities with the word or between them. So we're going to solve both of them, and I am going to begin by copying it, pasting it over here. That way we could show our work. More work. So here we go. Let's start solving the left one first. And on the left one, we're going to distribute -2 times x, that's -2x. -2 times -1, that's +2. I bring down the inequality greater than, bring down the number 6. Okay, now I need to still solve for x, so I need to get rid of the 2 by doing -2 to both sides. What I have now is a -2x, this canceled out, is greater than +4. And now my final step is to divide by -2 and divide by -2, giving us x is, I need to flip the inequality because I divided by a negative. X is less than -2, okay? Now we do have the word or up here. So I'm going to take that word or and I'm going to put it down here right next to that answer. Now I'm going to solve this one over here and write my answer over here, okay? So x is clearly on the right side of this inequality. So I need to get rid of the 7 first by subtracting 7 and subtracting 7. That will give me -2 on the left side, less than symbol, -8 on the right side. I mean -x on the right side, I'm sorry. And now for my final step, I am going to divide by -1 to make that a positive x. I don't want a negative x, I want a positive x. So I'm dividing by -1, dividing by -1, and my final answer will be x, positive x. Now because I divided by a negative, I need to flip the inequality symbol, and I get a positive 2 over here. So this is my answer. However, I want the x on the left side and the 2 on the right side, but this is my answer. All I got to do is read it backwards. X is less than 2 because it's opening up to the 2. That means 2 is greater than x. So let's just flip the whole thing, put the x on this side, the 2 on that side, and continue to open up towards the 2. So those are our answers. Now all we need to do is graph them to determine whether we leave it like this or we only write one of them. So here's our number line. Sorry about that, it's kind of crooked. We have a -2 on this side and a +2 on that side. So let me do this one in blue. X is less than -2. Let me do this one in red. X is less than 2. Okay. Now, the word or tells you something, right? It's like if I tell you in class, hey, if you have a black shirt on, stand up, or shorts, stand up. Or means it could be one or the other. It does not have to be both. It'd be a different story if I said stand up if you have a black shirt and shorts. Then it would have to be both. The word and implies both. The word or, just the first one that comes your way. So right here, it starts right here. Like it doesn't exist over here, but it starts existing at the open dot at 2 and to the left. So how do I say that it starts existing at 2 and to the left? That means x is less than 2. That's the only answer. So you're not going to write this one down. You're only going to write this one down. X is less than +2. I hope that makes sense. Now, if this would have been the word and, you'd have to write x is less than -2 because and it has to be both, the red and the blue. When it says or, it could be one or the other. So obviously I have a red right here. That satisfies it. That's why it's x is less than 2. I hope this helps, guys. Be ready for that test by studying this.